Our project was really just to design the frame, design the chassis.
It had to be four-wheel drive, all electric, and autonomous.
We cut with the bandsaw, cut everything to length that we needed.
For seniors in the William States Lee College of Engineering at UNC Charlotte, the culmination of their undergraduate studies is their year-long capstone senior design projects. In 2008, these projects ranged from a thermally enhanced cooling system to a racing lawnmower. The design challenges of the projects were varied, and the students had to actually build and test what they designed. For the team of mechanical engineering technology seniors Daniel Freeman, Ben Wright, and Michael Gherkin, their project assignment was to design and build an autonomous ground vehicle, as Daniel explains.
The scope of this project was to design an unmanned ground vehicle that could go over various terrain, off-road, had to be four-wheel drive, all electric, and autonomous.
The project was sponsored by Defense Technologies Incorporated, who specializes in unmanned aerial and ground vehicles for military applications. DTI set out the performance expectations for the project, but never revealed its specific use.
So our project is sort of open-ended. It's intended to be used as anything that the military needs. So we knew that we would have cameras on it. We knew that it needed to be GPS controlled. And our project was really just to design the frame, design the chassis.
The main project liaison from Defense Technologies was aerospace engineer Charlie Warren.
Defense Technologies came up with the idea of developing a ground vehicle to jump from one of our previous designs. We have a four-wheel robot that we wanted to expand on, and we thought using the university was a great way to do that. The big thing about this robot is its suspension system. We wanted this to be able to go out and drive through any terrain possible.
Starting with this expectation from DTI, the team then went to work to come up with a design solution.
We sort of went back and forth with our design. We would build it up and make a complex design, and then realize that it was going to be too heavy for the motors that we could afford, and then we would go back down and make it as simple as possible and save as much weight as possible, and explore that, and then find some problems there just with the dynamics of climbing over a 6-inch step. And
yeah, we actually did our CAD modeling on SolidWorks, where we had several different designs. We had a 6-wheel, a 4-wheel. I think we have at least 3 different 4-wheel designs. And SolidWorks allowed us to, show every dimension, just every part of it, and actually solve some of the problems virtually.
One element that had a major impact on the design was finding the right motors. If motors of a specific size, cost, and power could not be found, the team's plans would not work.
Our initial problem with the motors was that no one made a motor that could produce the torque that we required just for driving over a 6-inch step or a large obstacle for anywhere near the price that we needed. We spent a lot of time calling the manufacturers and going through what kind of torque their motors could produce and how long they would run safely that way, and how much heat they would generate and how much current they would draw.
The team found the motors they were looking for, and to ensure they would perform as required, did a series of load tests. The tests were critical because building could not begin if the motors would need design modifications to strengthen them.
We finally found a motor that would work from Bainbots, but we weren't sure how the output shaft of that motor was supported internally in the motor through the gearbox. We didn't know if there was enough support to handle the bearing load of a perpendicular force on it. So what we ended up doing was putting the motor in the Instron, mounting on the Instron, and having the Instron put a 70-pound force, which we calculated to be way more than any force that the end of any single motor would have, and it held up very well.
Putting to use real-world engineering skills such as Instron testing is one of the major educational goals of senior design. The hands-on philosophy of the course also develops a range of other professional skills, as faculty associate Dan Hawk explains.
The projects are reinforcing all of the hard engineering skills that they're learning throughout their 4 years. We also place a strong emphasis on project management, where in the beginning of the first semester they generate documents such as Gantt charts, requirements and capabilities documents that become the contract between the students and the sponsor. On the DTI project for the unmanned ground vehicle, we needed students that had a strong mechanical background and also good hands-on fabrication skills, since not only did this project require a complete design, but a functioning prototype had to be built and tested as well.
The building phase of the project started during the second semester as the team began the custom fabrication of parts and the assembly of the vehicle.
We all met down at the machine shop right underneath in the Smith building right here, and we cut with the bandsaw, cut everything to length that we needed, and milled the ends, so they're flush and flat. We drilled holes. We had a guy over in the motorsports department, and he welded some stuff for us, the knee bracing and things like that. And we had to mark them, so they fit perfectly back together.
The building phase of the project went well, with the assembly of parts becoming a whole that would perform as designed. The end result was a powerful vehicle with a very distinctive and functional suspension system.
This is our vehicle, fully assembled. This component here is the payload box. It has the batteries, the electrical components for the GPS. The center axle connects the two frame rails and the payload box.
We machined this center axle out of a solid bar of aluminum. We machined that so that it would fit into the sides of the frame rails and provide a bearing surface so that it would act as essentially a ball bearing or a bushing. You can see how the rocker bogie suspension system works. Essentially it's just these two frame rails connected by a center axle, and we have our stabilizing linkage here, which allows our large amount of articulation, while the payload box only moves approximately half as much. It only tilts back about half as much as the wheel does. Our motors are DC brushed motors, but they rotate at about 10,000 RPM, so that 108-to-1 gearing gives us a lot of gearing down, a lot of power.
Here's the motor case. Inside these casings, you can see the back of the motor here. The way we have this mounted, the motor casing and this frame actually acts as a heat sink. As the motor gets warm, this aluminum, the heat is conducted into the aluminum and dissipated throughout the vehicle. All of our wires from the motors and encoders are routed through the frame here. The wires come out on the inside of this frame and they go into the payload box.
In the field tests, the vehicle performed well, easily climbing obstacles far larger than the required 6 inches and meeting the expectations of DTI.
Absolutely, it's met our expectations. We really think this is going to benefit Defense Technologies, and we've already talked about taking it to a trade show next month. We're going to continue our sponsoring senior projects. We've already kicked around ideas for next year, actually.
In addition to meeting the sponsors' expectations, the project also met the educational goals of the College of Engineering.
The project was a success from the educational standpoint. One of the criteria that we have for our capstone course is a design, build, and test component. And clearly they've done an excellent job of thinking through the design aspect, generating mechanical drawings using CAD software, and then actually building, fabricating, and now at the testing stage. So from a senior design standpoint, I would consider this to be a great success.
The success of the team's design, construction, and presentation skills was also recognized at the end-of-year Senior Expo. The Expo is the final presentation and competition between all of the senior design projects. As judged by faculty and industry partners, the DTI ground vehicle was named the top industry-sponsored project of the year. But beyond the award, the project itself brought much more to Daniel, Ben, and Michael. Through the design, building, and testing of a real-world project, they learned valuable planning, teamwork, fabrication, and engineering skills. Skills they will now take to the workplace as they begin their engineering careers. The Williams States Lee College of Engineering, where imagination is realized.